Look, thanks for the opportunity to talk to everybody. I'm so disappointed not to be there. The pictures look fantastic. The event looks awesome. Talon is like a 34, 48 hour flight away from Australia, so not an easy thing to do. But congratulations to everyone for organising the conference. It just looks fantastic. Let me talk to you quickly about Evernode and where it's come from and where it's going. And I'm doing this conjointly with Gadget, who is there, and he's got a slice of the presentation at the end.
You've never seen me before, so
I have never seen it, mate. It's good to see you. So Evernode, we launched 15 January last year, 2024. We've now got, there's 11,200 odd hosts on our network. About 6,300, now about 6,400 are active. About 6,000 have what's called a good reputation, which means they've been up for an average of 80% of the last, well, they've been in consensus for over 80% of the last 2 days, last 2 hours. We have 41,000 instances, 7,200 of those are active. That means they're running contracts on them. And there's 22,000 slots that are in machines with good reputations. You can see number of CPUs, amount of RAM, disk space, like there's an enormous amount of computing power on the network. There are hosts in 24 different countries. The way that Evernode works, if you want to earn rewards, you can't charge above a certain fee for your space per hour, and that fee is 0.06 EVers per hour, which translates to about less than a cent US per hour. So it's a reasonably cost-effective network for hosting for computational resources. How do we get that large? Well, it turns out that incentives are the best incentive. We have a currency is issued on Zahara. Sorry?
Who would have thought that?
Yeah, I mean, what a surprise, right? Like, our token is issued on Zahara. You can hold it in any Zahara compatible wallet. We recommend Xamarin. You need Evers because if you want to be a host on the network, you've got to pay a registration fee in Evers. And if you want to be a tenant on a host, you have to pay the rent in Evers. We are now on a bunch of different DEXs and exchanges. You can buy Evers on the Zahara network DEX, you can buy it on the XRPL DEX, thanks to GateHub, who issues the Evers IOU. Fantastic, thank you very much for that. And you can get it from the AMM, Bitrue, Bitmart, MEXC, and CoinX. We recently paid also for the listing for the Zahara token on CoinX as well as Evers. The benefit of CoinX was that they were doing their own market making, so it didn't require us or the Zahara team to stump up extra capital and pay for a market maker to make that market, which is why we made that happen. And C14 Money app. I need to mention here, the XRPL DEX, our token trades often at least as equal as it trades on the centralised exchanges, sometimes double the amount of volume or value. And it really is a piss off that Ripple doesn't fund the necessary infrastructure for CoinMarketCap and for CoinGecko to report on DEX volumes. It really is just mind-bogglingly negligent in terms of its support for the general ecosystem. We're just invisible for that volume, and the same thing happens to Zahara. You look less popular than you really are. Finally, you can earn Evers. So again, this is the reward aspect. We have a heartbeat hook, so on the Zahara network that distributes our token as rewards to reliable hosts every hour according to the Evernode reward schedule. We have a max supply of 72 million. The account's been black holed, so that's fixed. much to the chagrin of every VC that comes and approaches us, because we can't just print tokens for them and they leave without even saying goodbye. 38 million is circulating. There's 33 million that's still locked up in the Heartbeat hook to be distributed. That's the values. Our host registration fee is 500 EVAs, and there's about 5.5 million EVAs locked up inside the registration hook. It'll take 118 years to distribute the host rewards. It is a regime. There's 5 million odd every epoch that gets distributed, and every epoch takes twice as long, so the reward schedule halves every epoch, and that's just the way those numbers fall out. We'll be up to epoch 4 in around about mid-November, and epoch 4, the rewards will drop to 640 an hour. At the moment it's 1280. No, it'll drop to 320 epoch 5. Richard designed this incredible system so that only reliable hosts earn reward. All of you guys would know that, you know, one of the challenges here is making sure people are running real machines and not just spoofing their existence on the network. What happens is every hour there's a hook on Zahao that sorts participating hosts into random universes of 64 hosts. So if you want to earn rewards, you register with the registration book, and that hook sorts everybody into random universes of 64. So UNL lists 64 in every UNL, and it gets shuffled every hour by the hook. Those hosts must deploy a small proof of work contract on themselves, the reputation contract, and then run that contract in consensus with its 64 host universe. Each host in the universe scores each other's performance and reports those scores to the reputation book, and you've got to maintain an average score of 80% or higher over 2 consecutive universes to be eligible for rewards. So that means you have to have a CPU, you have to have the computing power necessary to do the proof of work within the time frame. It tests for the existence of ports, it tests that you have the computing resources that you say you have, and it functionally tests your connectivity as well. If you're not in connection with your universe, then you won't score. And so what it means is that hosts only earn rewards if they continuously prove they can deploy contracts and supply the resources and connectivity to run those hosts in consensus with others. For those of you who don't know, quick talk about the tech. Evernode has 3 layers. There's a hot pocket, which is consensus as an operating system. It's based upon the Ripple consensus mechanism using UNLs, and what it does is convert any normal app into a DApp that runs inside a UNL consensus engine, maintaining shared canonical state across multiple instances. So it's agnostic as to what the app does. He simply takes inputs, applies the rules, gives an output, maintains a state. Those slots are on the second layer, then is Sashimono, which is a decentralized Linux hosting. It's a hosting daemon that divides the Linux machine into multiple independent slots, capable of trustlessly hosting hot pocket DApp instances. So it supplies the UNL consensus. So I can upload my app into multiple Evernode instances and then stitch those together in a cluster. And hey presto, I've got effectively a bespoke blockchain or an app chain. It's its own layer 1 network with its own canonical state, etc. But it's running on infrastructure I don't control, and it's decentralized hosting network. The final component is Zahao. If you've got a network, you need to know who's on the network. That registry can be highly centralizing. So instead, we've nailed it to Zahao using a bunch of hooks. There is a network, so there's the registry hook, which you use to pay in your 500 EVAs. You get back a registration NFT, proof of your hosting on the network. And any time you can redeem that hosting NFT for 50% of the amount on deposit. There is the Heartbeat hook, which distributes the rewards. So that's our treasury. There's the reputation hook, which manages the reputation contract and the sorting into universes. And there's a governance hook. So there is a mechanism where 66% of hosts can vote to change any of the hooks, and those hosts are those that have a reputation, that have a registration NFT and are earning rewards, so have a reputation greater than 80%. So it's a really sophisticated kind of DAO, if you like, and it's only possible because of the tech that Zahao provides. We make so much heavy use of Zahao that and there's so many transactions involved in this process that if we used any other tech, it'd be prohibitively expensive. But what has turned out to be absolutely magical is the rewards mechanism, what we call the balance adjustment, because our hosts can simply hold on to a sufficient number of ZAR, and that 4% covers their operational costs. So all of those concerns we had about people burning their ZAR in order to be hosts on the network, it's all just kind of vanished. It's just been absolutely fantastic. And I put that in there because I really encourage other projects to start exploring Zahao and hooks. We've been able to take what is otherwise an issued IOU, in XRPL parlance, and effectively turn it into a decentralised ERC20 token. The hooks makes it completely decentralised. We don't control the treasury. It's not Scott Chamberlain or Richard Holland walking around the world with multi-sig keys to control any of these tokens, etc. It's magic, and it can work for your project too, would be my pitch. What we get out of this architecture is a highly flexible, highly powerful mechanism for building dApps. You can build it in any language, all the popular programming languages. I think the terminology is POSIX compliant. Will work on an Evernode, anything that Linux runs. Any behaviour, so the dApp is as powerful as normal apps. They can connect to external services, read, write, store data, perform complex computations. Everything that you would normally do with an app, you can now do in a decentralised way using an Evernode dApp. Any geography, because you select which host to upload your application to, you can deploy selectively by geography or any other metric, and that way developers can avoid things like compliance headaches with GDPR. For you guys in Europe, you could ensure that your dApp only gets uploaded to machines that are based in Europe, and hey presto, you no longer have those cross-border data problems. And you get any scale or cost. You can selectively deploy to as many hosts as desired, and you can choose your own trade-off between cost and security. So it's incredibly flexible and powerful. The use cases for that fall into 5 main themes. Aside from everything else that smart contracts do, the stuff that this tech does better than anything else, and in fact does that other things can't even do, is these 5 themes. First theme is middleman be gone. This is mostly being handled by Ravi's company, EverPower Labs. GVO was the team that helped us build the tech. They've created their own spin-off company called EverPower Labs. And what you can do is any website can be transformed into a decentralised service owned by a community instead of a single powerful player. And he's exploring a bunch of use cases. Road Rush for ride sharing, so it's Uber without Uber in the middle. TripQ, it's hotel booking, booking.com without booking.com in the middle. Decentralised medical records. This is really interesting when he talks about this. There's a piece of AI on the client side that organises and interprets the client's medical records for the doctor. Trace Hub, which deals with provenance and supply chain management. Decredit, which is a microcredit, and GigFi, which is decentralised freelancer. So freelancer without freelancer.com in the middle. These are all things that what Evernode does is remove the need for the single powerful player, and instead everyone who wants to can run an instance, join a network, and have a community or industry-owned infrastructure. The second theme is cross-chain native. So Evernode instances can run submission nodes for other blockchains inside themselves, and that allows the dApp to be their own oracle or bridge. We've had the community do successful integrations for Cardano, Algorand, XRP Ledger, and Zahao. This is a really interesting use case. I didn't even think it was possible, but it's what it means is that the app doesn't need an oracle or a third-party oracle or bridge in order to connect to or in order to know what's going on a particular chain. You can actually include the submission node for that chain in each of the instances and make it part of the contract. So it is its own connector and knows itself what's happened on that chain. If it needs to pick up that a transaction happened, well, it'll know it because it's running its own submission node inside of itself and then transferring that information to the new chain. I think there's incredible benefits that can come from this sort of application. The third thing, decentralised Cloudflare. So this is a community-driven project. There's load balancing across multiple Evernode instances that can provide a decentralised alternative to Cloudflare. So this is the first live project, if you like, on Evernode. Third party, we didn't even know it existed, didn't even know it was happening. Sound Alive Radio. It's a radio station hosted on multiple Evernode instances, but accessible from a single web address. And Gadget did all of the magic necessary to make that happen. And if any instance goes down or is attacked, another instance just steps up. It doesn't rely on consensus, it just relies upon there being multiple copies of the same thing on multiple machines, and it can step up and serve the client from whichever machine is available. It does the same sort of load balancing that Cloudflare does, but it does it in a decentralised way. This is one of our projects that we developed during the development of Evernode, and this is an example of what I call sophisticated bespoke dApps. So unlike any of the other themes, this is just a dApp that requires all of Evernode's powers, like connecting to external services, minting NFTs, managing layer 1 assets, and storing on-chain data. There's this wonderful ability that you get from using Evernode and Zahao, where if you've got stuff that needs to persist, it needs to be an asset that really matters, well, that can get minted on Zahao and Evernode can pick it up. I don't know what I'm doing here. I don't know what it is. Sorry guys, I'm fiddling with my mouse. So digital cows is an example of that. There is a cow NFT that gets minted. Those go into vaults. From out of the vault, you mint a token that represents percentage share of the sale proceeds from the vault. Those tokens trade amongst hedge funds and other sophisticated financial people. And when the cow gets sold, the stock and station agent deposits the sale proceeds, turns them back into stable coins, puts them in the vault, and it auto distributes to the people. It's a way of doing synthetic futures for beef, because in Australia we don't have a futures market for beef. What we're waiting, all of these use cases tend to rely upon stable coins. Anything you guys can do to assist stable coins to come to the platform is exactly one of the things that needs to happen, because we need digital payment mechanisms for this, and stable coins are the way to do that. We can't do it by hooking up to people's bank accounts. We're waiting on streamlined regulations in Australia. When they come, then we can put some shoulder to the wheel on this project. The other final theme is AI juries, because we have, again, what you can do, because they're so flexible, you can actually run CPU-based AI agents inside Evernode instances. And once you run the CPI, the agent inside an instance, you can do multiple AI agents and force them to reach consensus with each other using the hot pocket consensus mechanism. And you can do that on A/B decisions. We have a project called Game Gods, where we're looking at using this firstly in the gaming industry, because effectively what you're able to do is you should be able to upload your text-based rules for a game and have the AI agents, effectively umpire that game for you. We are likely to have an architecture for this where there is a separate GPU-based AI agent that's responsible for interpreting and, suggesting the new narrative, and we would have on-chain AI juries, CPU-based, that would be responsible for reviewing what the GPU agent has constructed and deciding whether that it's canonical, whether it meets all the tests. You've you followed the rules and this is not a stupid narrative and you haven't, hallucinated something, and it provides a kind of governance or fiduciary layer to what the GPU is constructing. We have hired a PhD intern from a university in Australia who is currently on he's 1 week into an 8-week project on exactly this problem of looking at which CPU agents, what are the constraints, what can it actually do, and he's currently running live tests on the Evernode network because the compute is so price effective. Rather than do it on a test net, we're actually testing live on the live net. If this works in games, it's a use case that should work for online dispute resolution, online forum moderating, and even enterprise management, which if you could imagine, you've got, here's the text-based rules for the organisation's travel policy. Here's some tokens that represents everyone's travel budget. Enforce the travel policy and don't let people spend the tokens unless it meets the policy. That sort of thing should be possible using AI juries. I'll now hand over to Gadget. He's got a showcase on some of the tools that he has built or is building, along with other members of the community, to improve the experience and accessibility of Evernode for hosts and users. You ready, Gadget?
Yes, I'm ready, yes. Okay, hello. I'll start to build a site so normal people, I say normal people, but everyday people can easily use it without knowing tech as such. So it's easier to easily to obtain and use some of these instances. Loads and loads of instances, as you mentioned earlier, but it's hard to use those instances. The only way to use any of those instances at the moment is via command lines. You have to get the command line, you have to install the command line tools, you have to know all the ins and outs of all the different commands and arguments, and you have to get your seed vault in there, you have to get everything set up. But so I have developed something so it's easier to deploy, making it so more people can use the servers that are out there to deploy some of the easier things that they want to use it for. So started off with a simple explorer, so you can then see which Evernodes are run, because to do that they need to run their own front end, so you can obviously connect to each of those Evernodes and then deploy on that Evernode. Instead of having like a singular one that finds each one, obviously we want to decentralise, we want to keep it all decentralised. So each Evernode has their own landing page, so each is completely independent of each other. So each Evernode will have its own landing page like this. It shows the 3 slots, because each Evernode can have as many slots as they want. Normally they just have 3, which are dividing that server up into chunks. So each one is a like Sashimona, who described earlier, is basically a rootless Docker system. So each of those instances which is available is split of that server of compute power. So you don't want to have too many slots per server, otherwise that divides that memory, divides that hard drive into too many slots. So each one has like 3 slots normally on average. These ones have all been taken up, as you can see, but you get other ones, you get free slots, which you can then select and deploy. Once you've selected, and you can have an easy one-click contract deployment. I've made a drop-down. There's lots of different Dockers that I've pre-built, so you've got to choose from. So, and then once you've deployed, each tenant gets their own little panel. You can go in there and do certain Docker commands. You can get the logs from the Docker. You can restart it. You can re-pull your Docker. So you can obviously use your own Docker. So you design your own one. You can put that on there, and then once you've got that on there, you can re-pull it if you want to update it, as opposed to instead of having to remake it all again. So there's quite a few slots. There's quite a few ones I've already made and built. There's a simple web builder. We've made a web C builder because, as you said before, each instance you can cluster them. At the moment, this is more standalone. Each of these instances are completely standalone, but as he mentioned before, you can have them clustered. So each cluster is then its own blockchain. So you can have that standalone, like we've got the, like he explained about the Sound Live radio. Each one is a complete standalone copy of each other. But you can have it, instead of having a standalone copy of each other, you can have it completely clustered, so they can all talk to each other. So if one instance went down, you don't lose any of the data from each other. Yeah, so this is another one of the examples is a file share. It's a bit like a Dropbox, where you'll fire up an instance, and then you can use it as a completely decentralized Dropbox. You can put, passwords. Only you can download them, or you can have it completely open, so anyone else can download them. And you can cluster this as well. So not only is it on just this one single Evernode, you can cluster it so you can have it on 10 Evernodes over many different countries. So yeah, then anyone else can download many of those different Evernodes, but they'd all have the same file distributed between them. Yeah.
Yes, first question.
Yes.
Before I forget.
Yeah.
Maybe Scott, you can take this one. What about when you do file sharing? What about how do you deal with takedown notices or illicit content? Is there any point of view on that?
Yeah, so the way that Evernode works, each of the hosts has the capacity to terminate an instance at any time, and it's part of the rules of the network that when you pay the lease fee, you're not getting any promise that the lease slot will persist, and that's a function of you're meant to be deploying to enough hosts that your Byzantine fault tolerant. And so the hosts have to comply with whatever are the rules and regulations in their own country, and if they get takedown requests, etc., that's why every host, you've got an SSL certificate for every host, you've got an email address for every host. If we go back to the landing page, there's a bunch of, it's contact details for the host. So like everything on the internet, most jurisdictions have some form of safe harbour for hosting, for hosting providers. Generally they work on the basis that it's okay right up until you get a notice about illicit content or stuff that breaches copyright, etc., and you've got to respond to the takedown request. Well, these hosts are no different.
Okay, great. So that's an important.
Yeah.
For anybody who doesn't know, Scott is a lawyer, so he thinks things through pretty carefully on this. Okay.
Yeah, I'm quite proud of where we landed with Evernode. We got a clean bill of health from the lawyers in terms of it not being a security, and that wasn't easy given the way that Australian laws are constructed, etc. It's decentralised. Uphold agreed to list our token and then just didn't list it because the volume's not there. I think the same thing happened to Zahau, it's just been, but it's a reasonably legally compliant project.
Reasonably. What about supporting GPU hardware and stuff like that?
It's dependent on how
We looked at that. We had the concept of having superhosts. The problem is, one, slicing up the GPU isn't quite so easy, and two, if you have the superhost, it really fiddles with the tokenomics. Like, you almost need a separate network made only of GPUs that would then have its own token that would then only have one application, but it just doesn't quite work. It's a lot of extra work to do the GPU. And what we decided was, one, the CPU, they're making so much progress in terms of CPUs based LLMs that we're better off exhausting that first than we are to try and leap to GPUs. And I suspect that the AI jury structure of having CPUs form A/B consensus decisions on the quality of content that's being generated by GPUs, I suspect that's going to actually be a really nifty architecture instead of just having GPUs generate stuff, because they can hallucinate, they can come up with weird stuff. But if I want to use this for dispute resolution, the idea that I've got 3, 5, 10 AI agents that have to agree that this is a valid outcome given everything they know about the rules and about the state, I think that's just a more legitimate way to go. And I think CPU is going to be enough for that.
So how much CPU power do I get within one of those nodes?
It is very dependent on hosts. Some hosts will have a very big, I mean, you can contact the host and see if they can rearrange and have a bigger slot, or just, or a bigger CPU per slot. But yeah, it is very dependent on hosts. Some hosts have lots of hard drive space, some don't have hard drive space, some have more memory. So yeah, that's why there's a selection, that's why there's so many hosts out there. You can select what you like and which country you like, and you can contact the host and say, I'm prepared to pay extra or
I need a 32 CPU,
Yeah.
64 gigabytes of RAM host in North
Yeah.
Korea, and then maybe someone makes it happen.
yeah.
Okay.
If you touch the North Korea, we can talk.
Yeah.
There's an entire directory of nodes and their configurations, right? So you get your bare metal host, you install this stuff, and then you get to decide in how many shares you want to split your node. But this is part of the public information, so during the selection procedure where you want to deploy, you can actually make
Browse
a
through
decision
and see
based on
which
your
one.
own rules.
Yeah.
So just don't, the market will sort itself.
How does pricing work on that? Is it bidding per unit of RAM or per CPU?
It's per slot. It's literally per hour. So you get your instance and you pay for that per. They call it per moment because it's not technically an actual specific hour. It's done by transactions over the time, but it's roughly an hour. So you pay per hour. So you can use that CPU and that memory in completeness. You can run it to 100% if you want to. It's dependent on the host. If they shut, if you shut it down, you'd have to have many to keep that going. But yeah, there's no actual limit as such.
So the host puts a price on whatever they have out
Yeah,
there, and then.
but like you said before, the reward system. If they want to have the contract and have the reward system, their pricing has to be to a limit. They can't just put it to like 10 Evers per instance, then they won't get their reward. So then no one would ever
There
use it.
was a slide that
It's
showed the
sort of-
maximum they can.
Yeah. So
Yeah.
it sort of self-regulates itself. If no one will use them, they're going to use the cheaper ones, and then if it starts getting more popular, then people might start putting up the price and not have the rewards instead. So yeah.
So it's zero trade-off.
Yeah.
Yeah, it's the host trade-off really.
So if you're the only 128 CPU instance on the market, so maybe
This is
you
it.
can charge whatever.
Yeah.
And just
This
forego
is
your
it.
rewards.
Yeah, you avoid your rewards, but you're the only one offering that many CPUs and that much memory and that much RAM and NVMe and that they could then specialise in that section of that yeah.
Rewards are there to bootstrap the network. They're not there to guarantee profit. So at the moment, you're earning about 2.5 Evers per day, so about 30 cents US, at 35 cents US per day per host. It's clearly possible that you find a client that's prepared to pay more than that, and you don't need the bootstrap at that point.
Yeah, another question. I think Harry's been.
Yeah, hi Scott, it's Eddie. I don't know if you can hear me, but if not, Gadget, I'm curious. So kind of what we talked briefly about this morning.
Yeah.
So if Onami Press has these dynamic releases, which are in the form of a multimedia video, and let's say we are working with 10 different nodes, but we don't know how often one video will be asked to be, recalled. Does it have like a smart routing rebalancing where if I get 10 requests and one node can't handle it, it will automatically
A load
roll to
balance.
another node to be
Yeah.
able to serve that
So you could load
anywhere
balance.
in the,
Yeah, you could set it up so you could spread that load. You can. There's many ways to do that. You can either have it as one endpoint or one domain, and then spread that one domain over 10, 15, 20 Evernodes, and then that then round robin as such to each one.
And then
There's a
the
simple
account-
term, or you could have somebody in front of that, like dedicated just to do that.
So
and
the
have that host
accounting for
separately.
the rewards is done automatically for me?
So the rewards per host, yeah.
So you could do a load balancer in front of it, anyway,
Uh-huh.
right, which would distribute it according to the requests coming in, right?
Right.
Yeah,
So
you
we
could
do that in many things.
Yeah, there's
right?
many ways you can do it. You could host your own load balancer and then have your Evernode behind your load balancer, or you could host the load balancer on Evernode itself.
Huh.
There's so many options.
Yeah, so for example, the XRPL cluster and the Zahao cluster is load balanced.
Yeah.
Because you don't know how many requests are
No,
coming in, right?
right.
So then it figures out where it needs to go, so.
A good example is the Sound Alive radio. At the moment, they weren't sure how much, content and how much bandwidth it needs, so they spun up 2 or 3. They've had to spin up many more than that. The actual website is hosted on, I think, 5 Evernodes, but the back end, they've got another, I think it's 10 to 15 Evernodes behind that. So the front end is on 5, but the actual streamed radio is on more than that. It's on 15. So they've got lots of hosts, utilising lots of hosts, but in different manners. And but Sound Alive Radio is more static. They haven't clustered their back end as much. Their front end is not clustered because it's a static site as such, which is actually a PWA. So it's like you can actually install it as a mobile app. Yeah.
Yeah, very nice, thank you.
Yeah.
So has anybody built a dynamic scaling?
That's my question, yeah.
Yeah,
Sorry.
It's auto, sorry, what are you? It's auto scaling.
It's more so what's good. The main system that I've developed, what you were talking about the Sound Live radio, is it is load balance itself just by the nature of the DNS system. If you have lots of A records on your DNS, on your own DNS, and you have lots of them, it will round robin each one. And I made it so so it will then just hit the next one. If that doesn't work, it hit the next one. If that doesn't work, hit the next one. If there's lots of inrush to the domain, that sorts themselves out. It's like an inbuilt system of the of the internet. You don't have to have a dedicated load balance, but you can as well. It's just,
So like in sort of trad cloud infra land, like you can set up a serverless system and you can only pay for what you use, and and as it scales you pay more.
Yeah, you can add more Evernodes as it scales.
And how long does it take for it to spin up a new Evernode?
Evernode is more or less instant. It's the same. It's as quick as loading a Docker app.
Yeah,
You
so
know,
my question was, has anybody written a system which allows you to do that and say, okay, I can automatically spin up a.
You can. There's
only pay when you.
I will only pay when I
There's
use
a couple
it.
of developers. They call them nomad contracts, where that contract's in charge and got the ability to seek out other nodes and add to its nodes. So say if you've got 5 nodes, you could take, well, my limit is 5, and then one of your nodes went down for whatever reason, that would spin up another one. We're only on.
You can do the Nomad too, so that you've got.
Yeah.
So say you've got 20 instances, but you could use a hook to manage the same way that we use the reputation contract. Out of your 20 instances, you might select, say, 7, 8 that are the UNL for this period of time, and then reshuffle it. But you've always got 20 hosts that are in sync. They're just not necessarily the 20. You don't need all 20 to be part of the UNL. You can shuffle your UNL between a series of hosts and get a lot more resilience out of that. And as Gadget said, in early development, we have a Nomad contract where you can tell it, spin yourself up to 20 hosts, and after you've spun up to 20 hosts, randomly choose one host to shut down and go into the registry and find the next most reliable host and spin yourself up on that. And so it would move around the network, and you'd never be quite sure which machines it's being hosted on.
Nice.
So you could have something which is monitoring your traffic
Yeah.
and then say shut down or spin up.
Yeah.
Okay. That's
You
pretty
have
much
to
auto
build-
scaling.
At the moment, you'd have to build it. That's not
No.
as such, but there are tools out there. There's the Nomad tool, I think, is.
Maybe somebody wants to build that.
This is it. At the moment, see the landing page what I've done at the minute. There's quite a lot of out there that has now been updated into they're now slowly updating to the newest one. But most of that is manual at the moment. So you'd say if you want to host, so say the Sound Live Radio, they've got fiber. They did it manually. They selected the Evernode manually. They installed it manually, and then they clustered it manually, as such. And then but the web builder we've put on already, which is built like specifically for Evernode, it supports the clustering system. So you can go in there and you can see the hot pocket working. You can add, we call it side dish. You can add your own side dish in JavaScript, and then that'll then go through the hot pocket and then add all the different things from the different on the cluster. So you can then see it happen on all the other clusters. You can go in manually and have and add in the URL to each one, and then they'll all talk to each other from then on.
Yeah, so the tech now supports long-running processes, so you can have some files that are subject to consensus and other files that aren't.
Some are static, some are dynamic, yeah.
Great.
So you know the reputation system that you were describing before, so you partition nodes into groups
Yeah.
of 64, and then they
Yeah.
each vote on other people in the
Yeah,
group.
that's what the Evernode have built just for the smart contracts to pay out the rewards.
Yeah. So if you get lumped with dead actors, do you get bad reputation?
Yeah, they've recently, about 3 or 4 weeks ago, they did have issues with that. It's mainly because of the consensus engine wasn't run in the right time frames, in the way it called each other, and so they were losing sync with each other. But yeah, that's just for the reward system. But they've now got to the point where the reward system is really reliable now. Yeah, that is much more reliable.
So we had an unwitting, really hidden gate condition, and once enough people came to the network with powerful CPUs, they were shutting other people out of consensus. That's been addressed. But the main issue is if we have a thing called a failed universe. So if your universe has got so many dot hosts in it that you can't get to the threshold level of hosts reaching consensus, then the score is discarded and ignored by the hook, so it has no impact on your score.
Yeah, before, like you were saying, we got to the point where more and more they're upping the CPU because they were getting more better machines, and that was actually that was completely the consensus too quick, and so the older machines weren't keeping up with the newer machines, and so then all the older machines was dropping out. So then everyone was like upgrading their machines again. It's like, yeah, it's an arms race of CPU, but we didn't realise that was going on. Everyone kept thinking, oh, we need to upgrade our CPU, but it was actually making the reputation work. We didn't realise that, and that's still to do with the consensus time between each cluster. That was only had on stage 1. They have to reach consensus. That's reaching too quickly because the machines with the higher CPU are reaching it like within seconds, and then so all the ones that couldn't reach that. But yeah, they've sorted that out. They've got the consensus for matching, and yeah, the universe has worked really well now. So the reward system's back to how it should be.
Okay.
I think it's enough.
The information about the node operators, you said there's an email address and there's a geographic location and so on. This is self-reported. Does it get checked also by others? Or
When they first register, it's checked by geolocation, by IP.
No, the email address.
Oh, the email address.
I don't think that's.
email, yes, but
No.
No, email address has not been checked.
I
It's
can
not
get an
valid.
IP from the US, no problem.
Yeah, yeah. In some respects, there is, there is generic ones out there. It's maybe hard to, but they're all got an IP address, and you could validate it yourself as such. But the registration.
So is there
validates
anything
itself.
like them having to have a domain
But it's hard.
and using DNS or something to put in the key or something in as a text record or something like that?
Each host has to have their own domain system, and when they register, that domain system is then registered with the SSL. So you have to then obviously go for the authority to get that SSL system. They have to be valid. The DNS has to be valid. So in that sense, it's also.
For example, I can't cheat the speed of light, so if there's less.
Yeah, there are ways of cheating, obviously, but general, it's hard to do that.
Just because of GDPR, for example.
Yeah.
If there's a latency that's, I don't know, half a second, I cannot really trust it, right? But it's right next to me.
I'm not sure what you, as in like
like if I have to be compliant to GDPR and have to ensure, okay, this data is only in, I don't know, Germany.
Oh, I see, so you want to validate where your
And
host
somebody
is.
in Australia
Yeah.
says, oh, well, I'm in Germany because people there pay more.
Yeah,
And then he finds that the latency is half a second, and then he knows it's not in Germany.
Yeah.
Or I can suspect it's not in Germany.
Yeah.
yeah,
I guess some of the things which, you know, in the DNS itself, not only that, you could look at certain ways, especially if DNSSEC is is there on the domain, right?
Yeah,
Then you also
yeah.
have to say that maybe they can use a text record,
yeah,
a TXT record which actually registers whatever the Evernode address or something, and and you match that. You know, I thought maybe there should be some way to look it up, the domain, and see, like right now in the XRPL and Zaha, there is a TOML file which is on the.
yeah, that is saying that all of that can be
Self-reported,
spoofed.
yeah.
At some point it can do all this.
You can spoof it, all of it,
Yeah,
but then there's
this
some
is it,
recourse. You know, if there's a contact, there's something, there has to be some kind of
Yeah,
trust.
Yeah,
Which
yeah.
it's up to the host to prove that they're trustworthy, I guess.
I mean, to some point, you've got to trust the host to a certain level, because if you put it on there, they could just pull the plug on the host and you won't see them again.
At some point, it's real use that burns out
Yes,
the
it is.
fraudsters, right? So at the moment, it's being bootstrapped, and there's a limit to how much you can really enforce certain stuff. But it's kind of good enough. Most of them are inside significant data centers. And, you know, real use at the end of the day will burn it off and mean that rewards don't matter that much. You'll actually earn more from hosting apps than you will from the rewards.
Especially, you know, use special use cases like yourself, if you wanted more CPU power, then that would then evolve to a point where some hosts would then start providing that at a certain level of cost. And that would then self-regulate the actual system itself to a certain point.
Guys, I have to go. I've got to pick a daughter up from work.
Okay, and we have to go because we're going to have coffee now.
Thank
So-
you.
Thanks, Scott.
Thank you for listening to me. Thank you for the opportunity, and very sorry not to be there in person.
And,